Alright, I'm working on number 107. 107 part A and also 108, which asks me to balance out number 107. So for 107 part A, I'm supposed to write a skeleton equation for ammonium phosphate. Okay, here's ammonium and then phosphate. And this is in an aqueous solution. Okay, now in a separate color, I'm going to write out the charges for each of these polyatomic ions. Okay, ammonium phosphate has a +1 charge. Ammonium has a +1 charge, and phosphate has a -3 charge. Okay, so these charges tell me something very important about this molecule here. This charge for the positive one, tells me, if you remember the shortcut, I can just cross over my oxidation numbers, my charges, and that tells me how many of the opposite molecule I need. So that +1 tells me I need only one phosphate, so I can leave phosphate alone. But this +3 tells me that I need 3 of these ammoniums. Okay, so this is the correct equation for ammonium phosphate. Let me erase my aqueous here; it's really messy. So this is in an aqueous state. Okay, and I'm going to erase my charges because they've served their purpose. Alright, so going back to the problem, letter A, ammonium phosphate aqueous plus chromium 3. So chromium 3 in parentheses, that tells me that this is now a +3 charge. Right? Remember that from a few chapters ago? +3. And then chromium 3 bromide, and this is in an aqueous state as well. Now remember, bromide is a halogen, so that has a -1 charge. So just like before, these charges are going to let me know how many of each I need. So this +3 tells me I need 3 bromides. Let me write that in black there. I need 3 bromides, and that -1 charge tells me I just need 1 chromium. But there's always an assumed 1, so I don't need to write it there. Okay, so let me go ahead and get rid of my charges again, because my charges have served their purpose. So these compounds, there's a reaction that occurs, and I end up with, let me write the arrow in a different color, so, okay, so these charges combine to make, now, ammonium bromide. So ammonium bromide. Okay, again my charges, -1 and a plus. Now I'm lucky in that they're 1 and 1, so I don't need to mess with any parentheses or any other subscripts, so I don't need these charges. They serve their purpose. And I also have now chromium 3 phosphate. So chromium 3 phosphate. Back to my charges, -3 charge, +3 ion, 1-to-1 ratio again, so I don't need to mess with any of my subscripts. And that's what I'm left with right now. This is my skeleton equation for number 107. So what I have written here now is, on the left side, on my reactant side, I have all 4 elements that I'm working with. I'm working with an ammonium, NH4, a phosphate group, chromium, and bromine. Okay, and I also have in red underlined the area where I'm going to write the coefficients. Okay, so I'm going to do the same thing with my product side. I'm going to make a line there just to indicate how I'm going to manipulate this equation to finally balance it out. So I need to make sure that my ammoniums on this side match my ammoniums on my reactant side, my phosphates, my chromiums, and my bromides. So I'm going to locate the most complex molecule in this equation, and it looks to me that the most complex molecule is this one right here. I have 3 ammoniums and 1 phosphate, so I have 4 total players. Now remember, treat each one individually, okay? So for bromine or ammonium, I have 3. So right now, as it stands, I have, let me use a different color here, I have 3 ammoniums, okay, and 1 phosphate group. So if I just put a 1 here, just for starters, that gives me, remember this one will disperse into ammonium and phosphate. So that gives me with 3 ammoniums and leaves me with 1 phosphate group. So that means I need 3 ammoniums in this side. So 3 ammoniums. Okay, so this disperses to ammonium and bromine. Okay, so that means I have 3 now, right? So now that I have 3 bromines on this side, because this 3 distributed over here, I have 3. That means I need 3 on this side. So if I look over on the reactant side, I have chromium bromide. And how many bromiums are there already? There's already 3. You have Br subtext 3. So that means I only need 1 there. That'll give me 3 bromiums, because this one distributes to bromium, and I already have a 3. So I already have 3. Now this one also distributes over to chromium. So now I only need 1 chromium. So on the reactant side I have 1, which means on the product side I need 1 as well, because this will distribute to chromium and phosphate. So this one distributes over to chromium, giving me 1, and it distributes over to phosphate, also giving me 1. So that means I need 1 phosphate on the reactant side. Now look at over here on the first molecule. 1 distributes, let me make that in red, 1 is going to distribute to phosphate. I already have 1 in place, so I'm already balanced. So you can see the final product here. I'm going to erase all my arrows to kind of clean this up so you can view this a little bit more clearly. Sorry, it's the end of the day. Okay. I'm going to also get rid of my underline. Okay, so hopefully you can see now a little more clearly what just happened. So I wrote out my skeleton equation, which is required in 107.A, and then I balanced the equation which was asked from me in 108. Okay, so hopefully this was helpful. I have 2 videos so far, and that's for 107A and 107 Part C. So hopefully those will help you in solving B and D on your own. And if not, just bring your questions back to class.